this is the recorded video for week 8, day 1. Our question for today is, what is the tallest roller coaster in the world? You have 4 choices. Superman in Magic Mountain, Formula Rosa in Dubai, King the Car in New Jersey, or Top Thrill Dragster in Ohio. What do you think? Have you made up your mind yet? Which one do you think is the tallest roller coaster? Let's take a look. Superman in Magic Mountain is indeed the tallest roller coaster in California. Not in the whole world, but in the state of California, it is indeed the tallest. Formula Rosa in Dubai, it is the fastest roller coaster right now. But it's not the tallest roller coaster. Superman, for example, is 415 feet tall versus Formula Rosa is only 170 feet. How about Top Thrill Dragster? This is around 420 feet tall, which is similar to Superman in Magic Mountain. And our winners goes to King the Car in Six Flags Great Adventure and Safari in New Jersey. It is 456 feet tall. Let's take a look and see how it feels like to ride King the Car. King the Car is an upside down U-shaped track and it goes up around 45 stories up in the sky. Let's take a look. What do you think? Would you ride on that? Now, here's a big question. In one of the homeroom lesson today, it talks about the power of yet. And that is very important because even for the roller coaster right now, this is the tallest roller coaster so far at this point. However, it will soon be taken over by Falcon's Flight in Six Flags Qiddiya in Saudi Arabia in 2023. This is a very cool roller coaster. I really like the name because it has falcons, which is our Abbott Middle School mascot, falcons. Right here, Falcon's Flight, they are going to be breaking 3 world records. They want to break the world record for the tallest roller coaster, the fastest roller coaster, so it will be around 10 miles faster than Formula Rosa, and also the longest roller coaster. Let's take a look. That's Falcon's flight in Qiddiya in Saudi Arabia coming in 2023. Would any one of you ride that? Now, let me ask you another question. So today we talk about the tallest roller coaster, and we see that that's Kingda Ka in Six Flags Great Adventure and Safari in New Jersey. And we also saw that there is a newer one coming in Six Flags Qiddiya in Saudi Arabia. And we see all these roller coasters. They always want to be the fastest and the tallest roller coaster. But why is height such an important part in roller coaster? Does height has anything to do with potential energy or kinetic energy by anyways? What do you think? Go ahead and pause the video and think about it. Now, next, we are going to go through Stemscopedia, and you can also use the Peer Deck link in the description below if you would like to take notes as well. Have you ever watched diving competition? Which diver positions on the right demonstrate kinetic energy? Which diver position shows potential energy? In class, we have students put a yellow star on the one with the most potential energy and green star on the one with the most kinetic energy. What do you think? The diver on the diver board is not an example of kinetic energy. He is still and not moving, but he does have stored energy, potential energy. So this is referring to this person right here on the diver board. This person has potential energy. He will soon release that stored energy to become kinetic energy in the next two positions as he dives off the board and into the water. So right here we see that he has potential energy, but as he jump off into the swimming pool, we can see that potential energy is being converted to kinetic energy. Let's take a look at another example. Energy can be classified as potential or kinetic. There are two main forms of energy in a system, potential and kinetic. Potential energy is a stored energy. Kinetic energy is energy in the form of motion. Look at the picture of a person swinging below. The person shows how the swing moves back and forth as the person rides it. When the person swings all the way back at position A, so right here, this is position A, the swing pauses a moment. At this moment, the swing only has potential energy. The swing then falls forward, gradually gaining speed. As it falls, its potential energy changes to kinetic energy. So again, as we look at this diagram, we can see this is position A. As it goes down, we can see potential energy converted into kinetic energy. At position B, the swing has only kinetic energy. As the swing continues forward, it gradually slows down. Its kinetic energy changes back to potential energy until it reaches the farthest point in its arc, position C. So this is position C right here. Here, the swing pauses again for a moment. At this moment, the swing only has potential energy. It then falls backward through its arc. Its potential energy changes to kinetic energy, and the cycle repeats. So again, we can see right here, position A, position B, position C. Everyday life, energy and roller coaster. Check out the picture of the roller coaster below. How does the kinetic energy change? Is it the mass or the speed that causes the change? Mechanical energy is part of everyday life. Have you ever ridden a roller coaster at an amusement park? Engineers who design roller coaster must understand the relationship between potential and kinetic energy. For example, Engineers take advantage of potential energy when the coaster car is at the top of the roller coaster's first hill. This is usually the highest point on the coaster. Therefore, a car at this point has the greatest potential energy. As the coaster car rolls down the hill, its potential energy is converted to kinetic energy. At the bottom of this hill, the car's velocity is very high because it has a lot of kinetic energy, which propels the car up the next hill. As the car climbs the hill, its kinetic energy decreases because it slowed down. Right here in this diagram, we can see at this point that high potential energy and low kinetic energy. As it moves down, we can see that potential energy decrease and kinetic energy increase. As they move toward the second hill and to the third hill, we can see again increasing potential energy and decreasing kinetic energy. Now, let's try to apply this to our project. Last Wednesday, you get a chance to try out the website and to see the different functions. Last Thursday and Friday, you finalized your energy skate park design, took the screenshot, named your energy skate park, and added the description. Today, you are going to be testing your model, labeling the highest and lowest kinetic energy and the highest and lowest potential energy in your skate park diagram. The first three parts, this is the part that you did last Thursday and Friday. Right here in orange, these are the parts that we will be doing today. Let's take a look at this together. Step 1. Go to tinyurl.com/designmyskatepark. Make sure to click on Playground. You will rebuild your skate park. Click on Pie Chart and Bar Graph right here. You observe kinetic and potential energy as the skater goes through the skate park in slow motion. Afterward, you label the points in your Google slide. Let's do this together. In your Google slide, you should have your name already, the name of your energy skate park, description, and the screenshot. If you haven't done that yet, please take a look at my video from last time to take a look how to take a screenshot. Today, we'll be focusing on labeling. Let's go back to this website. Again, they do not save your skate park, so make sure to redesign your skate park and put it right here. It can be any design you want. Click on Pie Chart and Bar Graph. We will be observing one point at a time. I'm going to start with the first point right here, highest kinetic energy. This is the green bar right here. I'm going to put my skater all the way to the top and I will observe how it comes down. I will recommend you to do it in slow motion as you are doing the simulation. I see kinetic energy increase, decrease, increase again, and decrease, up and down. Alright, I want to find the point where the bar is the highest. So you might find that you have to do it a few times for each of the points to make sure you get a very accurate point. I notice when my skater is right here on the very bottom, my kinetic energy is the highest. I'm going to put that label in my diagram. There's a few ways you can put the label. You can drag it to your diagram. You can use the arrow right here. Some people also prefer using the text box. Some people notice that when they are dragging the label, that the text is going underneath the picture. If you experience that, you can do copy and paste and put the label right here. Now, let's take a look at the next point, which is lowest kinetic energy. When would they have the lowest kinetic energy? Again, I'm observing the green bar right here. It goes up, comes down, goes up again, comes down again. But what is the lowest point? Right here at the very beginning, I see that the kinetic energy is actually the lowest. I'm going to mark that on my diagram. I'm going to copy and paste it and put it right here on the top. Again, if you would like to use the text box or arrow function, you're more than welcome to do so. Now, I'm going to be testing the potential right now. I want to find the highest point for potential energy and the lowest point for potential energy. Let's see. Potential energy is right here. It's a blue bar. Now my potential energy is very low. I wonder when potential energy is the highest. I see that when they are right here at the very top point, potential energy was actually the highest. Afterward, it fluctuated up and down, but it wasn't as high at the very, very beginning point. So I'm going to mark that in my diagram as well. I'm going to copy and paste this and drag this on my diagram. So right here on the highest point, I see this is where they have the highest potential energy and the lowest kinetic energy. Last but not least, I want to see when I will have the lowest potential energy. Again, potential energy is this bar in blue. Now it comes down, goes up again, comes down again. Oh, that was a really low point. I wonder whether that's the lowest point. I see that this point is when the potential energy is extremely low. I'm going to label that in my diagram. Depending on your design, you might have multiple high kinetic energy or low kinetic energy or high potential or high kinetic energy point. You can label the one that is the highest. Okay, so right here, this is my diagram so far, and that's what I will have for my project. The name, all 4 points label, highest and lowest potential energy, highest and lowest kinetic energy. I also have my description to the right. If you have any question, feel free to email me. I'll see you tomorrow. Have a great day. Bye-bye.